So hello, we're here to talk about how you can build these systems and keep it running, because it turns out sometimes code is not the most reliable thing, as well as we are. So I'm Steve Lasker. I'm a program manager. I work on Azure Container Registry. I work on a lot of our end-to-end experiences on things like container lifecycle management.
I'm Glenn. I work on .NET, on specifically the server parts of .NET, most predominantly ASP.NET Core, as it says there. But generally things related to .NET running on a server as opposed to somewhere else.
If I take the slide away, you can forget what you do?
I would have forgotten what I do, yeah.
Okay.
Yep.
All right, so we just want to tease this up a little bit because it's very easy to jump into code and show all of this, but we wanted to put some context because oftentimes we get into this conversation of just because you can doesn't really mean you should. And that's kind of a theme around what we'll see today as we're talking about it. And the first thing is everything going to be 100% reliable? And that's the real question. You know, is power reliable? Is the network reliable? Is the OS and framework that you're based on, and the one that we actually ship, we know. And the point is there's all these things that you have absolutely no control over anymore.
My framework is 100% reliable.
Well, you can think that.
True story.
True. I'll show you later. And then we get to whether your code is reliable. And this is the whole idea of moving into the cloud with machines that somebody else is managing and networks and not even in your building is very different than the desks, the computers underneath desks, where the most unreliable thing was the power cord that somebody might have tripped over or the Ethernet cable. And everybody was connected to the same hub at some point. So the point is we're building out these systems, and we have to think about these components. So the question is, does it really need to be reliable? Is any one thing going to be there? And that's the biggest thing, is failure is a thing. And we can fight it all you want, but you can start to accept failure as a reality, because it's not a matter of avoiding it, it's really being prepared for it. And that's kind of what the nature of our programming model we're going to talk about today, because building these kind of systems assumes failure and can react as accordingly and either decide doesn't matter or actually figure out how to get to the service at another point. And that's the trade-offs. We're going to spend a little time talking about some patterns around coding for these unreliable services. Then you have to figure out where and how you're going to use them and when. Because there are costs associated with this. How much code are you willing to write? Test, right? That test part. And maintain. I'd like to be able to go home at night and hang out. It might be hanging with my kids, or maybe somebody's playing poker and drinking. I don't know. Whatever they want to do, it's kind of a bummer to get a call in the middle of the night. So how many redundant systems are you going to pay for? And how many regions? Because you do want regional support. But you need to pay for all these. My little 10-region deployment this morning was kind of fun. So as you're going through this, when you're working on these different services, just think about a couple of questions. If the particular thing you're working on fails for 5 hours, 5 minutes, does it even matter? And if it is really critically important, then what can you do to minimize your dependency on that? So
never try.
Never try. Just never try. Don't even try to make it 100%. And that's the idea. If you spend all your time coding to make your thing perfect, Murphy's going to come along and show you another way. Right? This morning I was doing this demo. I had 10 regions replicated, and it turns out we triggered some other bug as a result of that. So it was just, you got to think about it. So in this page, when HTML started, which was the beginning of the internet, right, it was already had some of these failure models in mind. What's the task on this page? Call for help. And the image is missing, but unless the image was the phone number, who cares? Now, if this was a clothing catalog where you're picking it by style, yeah, it's pretty important that those clothing images come up. If the images are for an airplane repair or something where the person already knows the part number and is not going to pick it out by the picture, then the picture is kind of nice, but not critical. So those are the kind of things that we want to tease up. Now, all of this is good programming. We should have been doing this for years anyway. It just so happens it wasn't as big of an issue because we had more things in our control. We built the server, we wired the cables, whatever it was, right? There was a lot more control. Now, that's changed. Now, the thing is we can write code that's resilient, but what about the infrastructure? And that's the core of things that has gone on for the last couple of years, is what do I do about unreliable infrastructure? And to get into all the fun debates around what's a microservice, because I can ask 10 people and get 12 answers, one of the critical things is it's redundantly, it's, what did I write here? Idempotent, so that it can actually recover from failure. There's smaller pieces that when something fails, they can just come back up and pick up where they left off. So this one I want to talk about around the infrastructure itself.
And this is how we set up this demo, right? It's built this way?
It actually is. So we've got the container builder, and the idea here is that it's not just a matter of doing Docker build, Docker push, but having an automated build service. In this case, I'm using the ACR container builder that we just shipped this week. And what we're doing is pushing to a registry, because a registry is the core of where you push your images that are built, and you can deploy them anywhere. And then the idea is you tell the orchestrator, run so many copies of these different pieces of my service.
Desired state, right?
Right, exactly, a desired state. I would like to have 3 copies of the web, 3 quotes, and 4 important things. And then once it's done, regardless of what orchestrator you're talking about, right? This isn't just about Kubernetes. This is orchestration in general. Its job is to keep things running, right? And it's got 2 of those. So now it's Thursday night. I'm headed out for Thursday night games with my kids or poker or whatever. And what's going to go happening at night? Well, I left. Everything was fine, worked fine in my environment. And lo and behold, something went wrong. But because we asked the orchestrator to keep n copies of these things, it did its job and brought it back up. Now that's pretty cool. Now, and it's not a bunch of people running around that their pagers went off. This was computers doing their work, right? This is the work that we're finally getting into the infrastructure to deal with the fact that things do fail. So that's the goal. The problem is if we build those things, if we assume failure like that, is your code capable of failing? Right? Is it going to get freaked out that the connection string is, or the connection is no longer there, and the thought that it should never go away? Those are the kind of problems that we want to talk about. So we were messing with trying to figure out what app we were going to build. You can go to it up there in the top right corner. You can just click on that. We've planned ahead. So we thought about wanting to show something unimportant that we could code and show failure and say it doesn't matter. And they had the important thing, and we figured the unimportant thing, we were quick to come up with quotes. Played with a couple ideas, but that was fine. And then we were debating on what should be important. And we couldn't come up with an important thing that didn't require weeks of development, so we called it the important part of the site. So that's about the extent of it.
You could fill in important with something important from your own lives, I hope.
And what we did is we basically made it so that you can't type text in there.
Thank you, all of you who have filled up my back buffer with messages already.
Because we know better. We've seen those demos. And then this is the site that we're currently dealing with, and we'll talk about some of the problems. So do you want to bring up the site and poke at it?
No, but you can.
OK. So we've got the site here, and we actually have it in 2 locations. We actually have it in East US, which is the one that you can get to. And we basically just keep on refreshing the page. And we have these silly quotes at the top. The original idea was you were going to submit quotes. That turned out to be a scary idea. So, and then we actually have it geo-replicated to Europe as well. And Glenn was nice enough to remind me that apparently I made an assumption that everybody in Europe is Spanish. So the concept was you can separate your configuration and you take it from there. So now the thing that we wanted to do is make sure that quotes could be unreliable. Let me just make sure that this thing is up here. So I'm just going to come, yeah.
Almost 200 people have clicked the button since you've been standing there.
All right. So let me just bring up the Kubernetes dashboard, and I'm going to play whack-a-mole here. And we're going to we're going to just knock out one of those nodes.
So if you saw that picture earlier, we had the web application, it was calling the quotes API, and then the submit was going to the important thing, right? So he's about to go and turn off the quotes API, and then the application is going to do whatever the application does when the endpoint is trying to do a HTTP GET against is no longer there, right? And he's going to do that by, I think you're going to go to Kubernetes and turn down.
Oh yeah, I was doing deployment. Sorry, that's why I was confused. Right? So right now we've got one instance, and I'm just going to make that 0. I could have just shot it in the head, but it would bring itself back up. And we actually want to show a complete failure here.
Yeah, so all of you people clicking the button, the nearly 300 of you apparently, refresh now. See what happens.
Yeah, you're basically just going to hang there, and if I didn't hit reset, eventually it's just come up to failure.
Yeah, so this is basically the timeout here. It's waiting, trying to resolve the quotes API name and failing miserably is what's happening here. Because we didn't build this application with any kind of resiliency in mind. It just says HTTP GET against the quotes, and that's it, right?
So this is not the important part of the site. It's broken.
Yeah, I'd say it's pretty broken.
And they're going somewhere else for their important stuff.
Okay.
So can you fix this? I want you to fix this.
Yeah, I can. I best move away from this. This is all the data that people have filled in since we started. Okay, so let me run you through our application really quickly. There is an index.cshtml. This is a Razor Pages app. This is the quote of the day section. I think I'm going to change this, because that's apparently what it is. And then there's the text box, this box down the button for submit, right? That you guys have been happily hammering away at since we gave you the URI. And then in our page behind, this is our page model for our Razor Pages app. It takes this thing called an iQuote client. So I basically, ahead of time, we're already wrapping our HTTP client here in a kind of repository pattern. And I'm going to show you how we're going to extend that into a HTTP client factory later. You may or may not be doing this. Maybe in here you were just newing up a HTTP client and using it in your controller. Are a bunch of you doing that? Just like creating a HTTP client, doing GET, calling life good? No? One guy? Very good. I love your honesty. Thank you very much. So then in our onGet, so every time you go to this index page, it says, go get me a random quote from this repository we created. All right? And what it's doing is it's newing up a HTTP client, and then it's just saying, go get me the quotes. Get me a random quote, ensure that it's a success status code, and log if there's an error, and then bubble it up. Just rethrow it. Right? So what you all probably should be seeing is, if any of you waited for the timeout for that when we turned off the quotes API, eventually you're just going to get like a 500 from the server. Because nowhere in that code that I just showed you did I catch and actually handle the exception. So first thing is, what are we going to do if there's no quote available? There's a couple of things we could do. What do you want to do?
I think we can just get rid of the quotes. I mean,
you just hide the quotes?
That's one option. I mean,
sure, we could do that. We could hide the quote. So in that case, we would like return null.
Yeah.
And then over in our UI, say if quote null, just hide this whole section of the page. That seems pretty reasonable. Yeah?
Yeah.
Or...
wasn't that just like May 4th be with you?
Yeah. So yeah, you could. So what if we just return a quote that says, everything's fine here now. How are you? Who
wrote that? Who said that?
Yoda said that, right? No, Spock. Spock, yeah. Someone is twisting, so they can't handle it, right? Right, and I believe that is a kind of probably
Spock? I thought it was Han Solo.
That's the joke.
Oh.
Okay.
Clearly we've been practicing this one.
Okay. All right, so now, if I can control F5 this, on my local machine, I actually don't have any quotes API either. So here is a very good test of what happens when the quotes API isn't there. I'll just F5 it locally. And what happens? Everything is fine here now. How are you? Seems great, right?
Seems good.
And then every request. Now, notice how it's still spinning for a little bit. Like, this gave us what happens when an error occurs, right? So we're handling that now. And basically the whole point of that was think about the data, Does it really matter if it's always accurate? Maybe I was pulling this quote from a cache from when it did work earlier on in the day. And when you were getting quotes, I was keeping a cache locally. Or maybe I have pre-canned results that I return. Or I do nothing. This happens a lot with Netflix microservices. The special personalization service is down, so you still get personalized results. They're just not as good. The example we were going to throw around was the hotel service. Maybe we don't sort the hotels the way that you did last time you were here because some of our stuff is down, right? Degrade as gracefully as you can. So now the problem here is we had to time out. Like the error when there were no instances available, at least it took a really long time before you got that thing. So now let's switch this up a bit to use some new .NET Core 2.1 features. So today I was just adding my quote type, the thing that was wrapping HTTP client, adding it as a singleton, so it was always available. I'm going to change this to add HTTP client, right? And then I'm going to change my quote type here to accept a HTTP client. Now this is how you use what we call a typed client in HTTP client factory, new into ASP.NET Core 2.1. There's going to be some stuff from Dan Roth later on, and I believe Hanselman may mention it in some of his talks later for more details on exactly what this does. We're going to focus mostly on how this enables resiliency in this talk, but it also manages the lifetime of HTTP client for you. So now
you're setting this up in like the root of the project, so I don't have to do this every time.
Yeah, this is in configure services. So what we're doing here is saying I have an endpoint. The endpoint is the quotes thing. And I have some policy that I want to apply to that quotes endpoint. I want to have a particular timeout. I want to have a particular retry pattern. I want to use circuit breakers in X way. And what this lets us do is configure that here in our configure services in our startup CS, define that policy once, and then just consume it everywhere else. So what we're going to do here is we're going to say add policy handler. Have any of you used Poly before? Excellent. This is Poly, like literally Poly inside here. It doesn't really wrap Poly much. This is just a straight up Poly timeout, right? And I believe this has to be HTTP response message because this particular timeout policy is being applied to HTTP messages. And I may have got that wrong. Yeah. No. No overloads take 0. I need to tell it what the timeout is. 30 seconds. How's that?
It's a long time.
Yeah? Okay. 5 seconds. How's that? Okay, so now when I control F5, so the way this works is you build up effectively an outgoing middleware pipeline. So every time I use the HTTP client inside this quote client, it's going to have this timeout applied. If 5 seconds ever elapses, then Poly is going to throw timeout expired exception, right? So if 5 seconds is enough, I'm not sure if 5 seconds is short enough actually.
Oh, that's true. We do
that. So in here I'm saying no such host is known. Let me zoom in on that for you. So this is saying the error that I'm getting in my logs is I can't find the quotes API right now. So if I were to make my timeout be, let's say, wrong Visual Studio instance. If I was to make my timeout in my startup CS be, say, 1 second, which is too short even for the DNS resolution failure that's happening here, then F5, what I'll start to see then is this Poly exception being thrown because the retry is expired. Okay? And that'll be here. So yeah, now I have this Poly timeout rejected exception. Right? Okay, so that's cool. So now I've got control of how long I'm willing to wait. I could also set a timeout on HTTP client itself. I could configure it here, in which case HTTP client would be the overall time that all operations through this pipeline could take. This particular timeout here is how long this exists in the pipeline. And that matters because if I were to go to here, so let's talk about retry. Today, this code is just going to say, try and hit the quotes API and fail after a second. Sure, we've said the fact that maybe this thing is going to go down, but if the reason that quote, if I happen to make that request at the second that the orchestrator was moving the container around or something, then if I try again straight away, it'll probably be back, or I'll get directed to a new node or something like that, right? So what I probably really want to do here is optimistically say, it'll probably be back, right? Like if the orchestrator is doing its job, it might not be here right now, but it'll probably be back soon. So instead, we have this method called add transient HTTP error policy, which basically catches any kind of what we think is probably a transient HTTP error, some 500s, a couple of 400 codes. There's a list in the documentation. And then in here, this gives you a policy builder, and you can say policy builder.retry async, and we can say retry 3 times, right? So now, what our HTTP is going to do is, it's going to retry every request 3 times, but every individual retry can only take 1 second, right? Because
there's a funnel
because
here, right?
because the timeout is after the retry. So you imagine this like a pipeline. The request starts, it gets to the retry policy executes this one, it goes through the timeout policy throws, gets back to the retry retrieves, timeout policy throws, goes back. Does that make sense? If you wanted the timeout to be 1 second for all retries, so all retries could only take 1 second, then you would move this up to here. Make sense? Just like middleware. Okay? So now our API is going to retry 3 times before it gives up, and each retry can only take 1 second. Probably want this to be a little bit bigger than this, right? Say 5 seconds. And then the next pattern that we're going to talk about, I think everybody's familiar with retries as a concept. No, most of these concepts aren't new, it's just how you might now implement them is probably
How much code would you have had to write to get that same thing?
I don't know, I would have copied and pasted it from somewhere else. So, the next thing is circuit breakers. So what our retries are doing here is, there's an error, our quotes API is going down. Maybe it's going down because you wrote some SQL queries and that thing is talking to the database and you don't have any indexes against the query and the query's taking a long time and slowly your API is going down, say. What that means is that you've now added 3 times the amount of load to that API that's slowly timing out in the background. So now the first timeout happens because it's still executing a query on the server, right? And then you send another one and it's still executing the query, and then you send another one, and then it executes the query 3 times, and then whilst those 3 queries are happening on the server, 5 others come in, and all you've really done here by doing this retry policy is put 3 times the amount of load on your API that's already going to go down from the load that it's eventually got.
That's the same theory if I keep on pressing the button on the traffic light to cross the street.
Yeah, they don't do anything anyway.
Or the elevator.
So that's the problem that we have right now, is we're basically just going to fan out, sorry everybody listening at home, and we're going to just backload our app, load up our server. Somebody in here is smiling and going, yeah, I've done that before, I've seen that, that guy, yeah. Okay.
He was on the other side of it, going, I can't get the thing up, stop asking.
So the next thing we're going to do is we're going to say add transient HTTP error handler.
Actually, in all seriousness, there's like some real patterns here that caused significant failure. Was it the airline one a couple of years ago?
Yeah, there was the book that introduced circuit breaker that I first read was about an airline. It brought down this type of error that circuit breakers would have helped with. It brought down the ticketing system on the computer at the front of the airport, and turns out they don't hire enough people to handle the load anymore because the computers take so much. So that was a bit of a disaster. Time span dot from seconds. Let's say 20. Okay, so now let's describe this. Maybe you can work out what's going on here. So now, let's get rid of this, so you can see all the code. So now, every request that I make via that, without changing any of my other code, it's going to come in, it's going to go through the retry, into the circuit breaker, into the timeout, right? Timeout throws. Then the timeout throws, it goes back, circuit breaker increments a count, gets to the retry. Retry sends it back to the circuit breaker, back to the timeout, timeout fails, circuit breaker increments a count. Once it does that 3 times, circuit breaker stops letting anything in anymore, and it just throws straight away. So now, when in your code, you're just saying get quotes. But if you've had more than, in this case, 3, if you've had more than 3 failures of this pipeline before on this node, it just instantly throws. And it doesn't even try and talk to the network. After 20 seconds, it'll try and let one through. And if that fails, it'll be open again. And then it'll just throw. Right? So now, what you'll see here is if we were to control F5 this, what you observe with this is your first page load takes a bit. Now, I happen to line up the retry count with the circuit breaker count. So after one full retry round, the circuit breaker has tripped, right? So now, I can keep refreshing. You can see the text changing really fast, right? Because the circuit breaker is open. After 20 seconds, I'll hit a slow one because the circuit breaker will be closed. It'll try and let me through. It'll do the whole retry dance, and then it'll fail, and then it'll be fast again, right? So someone will pay the cost of hitting that slow request, but once it's gone through and we're like, okay, it's down, don't try anymore because it's probably dead, right? Make sense? Yeah. Has anybody tried to do this before without something like the framework for help? Okay, yeah.
They're the ones that we copied the code from.
They're probably all the people that said we've used Poly before. So one thing that you will also see in here is if I've got trace logging turned on in here, so there's lots and lots and lots of logs. Look,
this is a great way to fill up logs and test your log size.
So right back up at the beginning here, you can actually start to see retries happening. Excuse me. And you can see retries happening. You can see the exceptions being thrown, and you can see in here how long your outgoing request took. And I need to clean this up. So if we run this again, Control F5. Make this big and big in this and scroll up here. Then what you'll see here is, see these? Whoop, there before it threw. These are all retries. So it's like retry, 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 retry. Circuit is open. Circuit is now open and is not allowing calls. Because the way the circuit breaker works is it throws an exception. We catch that exception in our quote client handler and we logged it, and then we returned our important Star Wars quote, right? So you get in the logs, circuit breaker is open. And you also get down here how long the request took. So it took us like, what, 7 seconds there to do that? And there'll be more logging in the future, I believe. We're working with Poly, so you'll be able to get logs from Poly, inject it straight into the log system, so you'll be able to see it recounting and incrementing the retry counter and stuff like that. So this is good, right? Great. I don't even know what branch I'm on. I don't care. Okay. I hope that your CI system is pointing at master.
Well, actually, we can see it. It actually did, because we remember to switch it over.
Okay, great.
And you can see at the top, it's triggered, and based on the trigger of a git commit, and now it's building, and we'll see it stream out.
Cool. All right. So what was that URL then? Demo 42?
Yeah.
AKS demo 42?
Yep.
Still running deployment.
Well, so I did turn it on.
Now, whilst, don't turn the quotes on.
Oh, don't we turn it on?
So whilst that's deploying, it takes about a minute to go through the entire CI/CD pipeline. I'm going to talk about what the important part of our app does. So in our index.cshtml, like in our post data, every time, for all of those of you who went and clicked the button, what was happening was I was validating the data that you gave me was in the word list that was pre-approved. Thank you, everybody who tried to send me data that didn't work. Then it just adds the message to a message queue, in this case an Azure Storage queue. And if I go over here to my important worker, this is just straight up Azure Storage queue stuff. So these, turns out that whole time that all you guys were clicking the site when it was working, our important API was actually down. Because we never had a queue worker that was processing any queue messages. You were clicking the button, it was saying yes. Nothing was working on the back end, it was all broken, right? But you didn't know, because Azure Storage queues have like a ridiculous number of 9s availability. They were geo-replicated, like the SKUs were, it was adding the messages to the queue, no problems. But it turns out we weren't processing them yet because we had a bug in our thing. In this case, we let Steve have admin access to the Kubernetes cluster. And as such, we have no workers running anymore.
That's what happens when you let devs play with dashboards.
So if we go back to our page now, though, is our deployment done?
It's just finishing up.
Just finishing up?
I am reloading it just to.
So
we'll go. You want me to turn it on now?
Depends what's off.
Your quotes is off.
Quotes is off?
Yeah,
that's fine. Leave quotes off. It'll be fine. As long as master.
Oh, the new one is refreshed. Yes. Sorry.
Cool. So theoretically, I should be able to refresh this, and my app will come back. Yeah. Okay. Everything is fine here. Looks great. Now you all know that means it's broken. So and now if I refresh here, you see this. See, it's a little bit slow. It's kind of spinning. It's doing all of its retry things. And now, what if I refresh now? Yeah. Okay. Yeah. Doing this thing. Cool. And eventually here, the circuit breaker would trip. Potentially, I have multiple nodes here, though, which I might be bumping around between. So, like, you never really know what's going on here. But it seems kind of OK. And if I click failures service, I can still submit stuff. Now, right now, we have three like APIs running: the HTTP quotes API, and everything. The only thing that's actually running is the web app. Everything else is broken. But you can still submit messages on the important part of your site. And if Steve goes and turns on the quotes API,
yeah, let me see something.
Like a good little admin.
A minion? You want me to be the minion?
Not the quotes API. I don't care about quotes. They're unimportant.
What do you want? Oh, you want that one to go away. No, let's put the quotes on.
Processing
let's show your things working here first.
Okay.
All right, so quotes are up.
You have 1 minute. Go.
Well, it's already working. Isn't it?
Nice.
Actually, that one's working. What did we break?
What do you mean, what did we break? We broke everything.
Apparently we did. All right, let's go. Han Solo just doesn't want to go away.
Yeah, so you can see here my circuit breaker was open here because I was able to refresh fast a bunch of times, but then my retries timed out. Okay, so turn on my queue processor, please.
So it turns out we had the queue processor off, so we got this queue worker. So we're just going to tell it to come up to, well, we got a lot in there, so let's kind of make it go away fast.
It's got like 438 the last time I refreshed the queue browser. 590 now. Okay. So now he turns back on the back-end processor, and as you would hopefully expect, way down in the bottom corner here, which you might not be able to see, all of you are pressing this button as fast as you possibly can.
Let's give it some more.
Right? It's like so look, 706 messages.
See, but the problem is they're really hitting on it as we're going. So
yeah,
I got to keep up. See, now this is a race.
So what you'll
I didn't think about this.
Yeah, what you'll see here is
because he put like a one. What was the delay you put in there?
It takes 1 second for each message to process. Right? And each node only does one at a time because I didn't spend much time coding it. So as you refresh here, you can see the top one changing, but it's still going up. Okay, scale up more Azure, more Azure, go. Okay, but this is the idea, right? Like, so right now, our system actually can't handle the amount of load that you guys are putting onto it, but it's still fine. At no point has your experience been degraded. And we just did that with a fairly simple, we've stood up an Azure storage queue, and we have this one class inside an application using a new generic host builder in ASP.NET Core. It's just, I implement this one method, and all it does is dequeue messages, right? And this is it, right? So there's probably like 100 lines of code in this background queue worker that's pulling messages off and sending them somewhere else. But look at the resiliency gains that we got.
Did it catch up yet?
I don't know, it doesn't really matter.
No, it does matter. This is like a little competition going on.
How many nodes are you up to?
Well, I'm bumping it up to, I don't know, 98.
Oh, look, we won! Yes! 36 queue workers.
I finally had to bump it up to 36 to see.
All right.
But you notice we didn't actually ever really put a dent in our cluster either. So that's kind of the beauty of it, is I can just throw more, and it wasn't like it had to provision a bunch of VMs or anything. Yeah. So anyway, so that was kind of fun. PowerPoint, that way. So, all right. Where's our, okay, so there's our demo. So what we did was we took this piece that we had up here, and we kind of rewrote the code to refactor. So our web front end was there, and we wanted to kill off the other capabilities. And we just wanted to focus on the most important task for our users.
So you imagine here, so we showed you this. You guys went and pressed a button when all we had was several web front ends and a background queue, and the entirety of the rest of our stack was actually completely blocked, right? And you were still able to go. You were able to submit click on the submit button and have messages put into the system. And that just relied upon my many web front ends in order to get us high availability of our many front ends and the availability of Azure storage queues, right?
It turns out we actually only had one web front end that we
did only have one web front end, but that was okay. And yeah, in this case we did, but you would have more because you want the availability, right? Does that make sense? Yeah.
And then we just did, we had this in GitHub so you guys can make availability, triggered on a Git webhook, Git hook, and then we triggered it with the ACR build into the registry, and then we used a Helm deploy out to the cluster to spin up those nodes.
And you're going to go through a bunch of this later on in your talk, how the ACR bit worked.
Yep. So I'll drill in tomorrow on, not just on this, but actually how do you do OS and framework patching on this as well. And just to show, we actually have this. I don't know if I showed this before or not. So we have it here. Did we push the update here too? Oh, we didn't actually do anything else that you would see an update here. So that's not a fair chance. So it was actually deployed there as well.
You can see it says unimportant. I added unimportant.
Oh, okay.
So we did redeploy from my machine. You guys saw me add unimportant to the beginning of the text, right? Yeah.
So it's automatically deployed.
So we deployed to two different regions, and if you put a load balancer in front of those two regions, you could hit either region as well, right?
Right, but in this case, we actually wanted to have, we have complete separate clusters, and we're trying to feed different audiences, just so you can do it either way.
Yep.
All right, what else do we got here? Oh, and the idea is that you could pretty much play whack-a-mole on the entire cluster, and we focused on what was the important thing. Yep. Right? You didn't, as users, you didn't care when the important thing got processed. You just wanted to submit the important thing.
They wanted to submit a lot, turns out.
Apparently did.
Yeah.
All right, this thing started at 75 minutes. How much time do we have left?
We have 8 minutes left, or 9 minutes left. Great. 8 minutes, I think.
So I kind of think it was like, this is like chasing chickens, trying to make things reliable. Anybody chase chickens?
No.
No, that's not true. People have chickens in their houses and their farms. That's weird.
Have kangaroos where I come from.
Well, you want to chase a kangaroo?
They're a lot faster than you are.
Oh, well, they hurt a lot faster, too. So, you catch a couple, and there's just more everywhere. So the idea is don't try to, it's not that you don't want to try to make your code resilient, but don't go for that last mile. Right? That's kind of the key part.
Yeah, I think the point here is like be aware of which part of your stuff is really critical and which parts of it are not, and try and pay attention as appropriate, right? And try and think about. So this concept has been around for a long time, and I think the first time I started to hear about it was when first listening to like Udi Dahan talk about service-oriented architecture, which was, is there any such thing as a race condition? If you ask the business owner, is it okay if somebody calls me and cancels an order just as I'm shipping it, the answer is probably, yeah, just like tell them to send it back or something. And if they do, we won't charge them. And if they don't, we will, right? Or something, right? And so it's kind of reevaluating your look on your UI. Obviously, by default, your customer is going to say, obviously, I want that quote to be there every single time. That's why I asked for you to put a quote on the page. And you're going to say, but is it okay if it only changes once an hour, or it might be the same quote for an hour if there's a problem, but most of the time it's there? And the answer is probably yeah. Is it okay if
show them the check, the bill
is it okay if this data is only actually is it okay if this data is an hour old? Questions like this are asked, and if you ask them the appropriate way and you actually think about it, eventually you get to a point where you'll understand exactly which bits are the most critical and have to be up all the time for submitting, and which bits are like, yeah, that's kind of important, but if it's an hour out of date, I don't care. And then you're like, great, hour cache. Yep. Right? My thing only has to be up for 1 minute every hour or something, right? I don't know what the 9 availability of 1 minute every hour is. Okay? So just think about the types of data that you're handling, think about the strategies you want to do. If you're going to do all of those retries that we just showed you, make sure the service, and for posts, make sure the service you're posting to is idempotent, right? Make sure that retrying isn't going to have you send the same thing twice, right? There's a lot of concerns you need to think about here, right? Cool.
And the big part is here, this is a paradigm shift. Working with containers is really about enabling that ability to package your code. It's also about a packaging format for deploying unreliable services. So this is kind of like my little twist on it is these things are unreliable and it's okay. But you really want to adapt to this model full bore. If you try to take small pieces to it, you wind up dealing with all this infrastructure problem or other parts of it that just, it's kind of like trying to make a horse filled with gas to get there. Like you need to get to a car. And then when you get to a car, you want to go from a gas car to an electric car, whatever it is. You need to really fully adopt that paradigm shift, or you're really not getting the benefit. It winds up just being harder.
Okay.
It does take time. Like, we've been working on this for a couple of years. You always hear people presenting on Docker. I've been doing this for so many years. It does take a couple of months. I like to think it takes 3 months to really fully understand and adapt, because we're so trained to looking for something that's so cool that we find the first one and we're like, awesome, done. And a week later, a month later, you're going to be like, I didn't know what the hell I was doing back then. This is like really cool now. So
every
take
time
it,
I do file new.
So just take it bits and pieces, but don't assume you're going to figure it out right away, and don't try, because every time I look at this stuff, there's new stuff. And even when I do figure it out, they change it. Like Helm is a whole new way of just dealing with templates for being able to deploy things.
You show Helm stuff in your other thing as well, right?
Yeah, I'll show a little bit. I won't drill into too much detail.
Okay, so this is stuff that I showed. I showed retries with HTTP Client Factory. I showed retries, timeouts, and circuit breakers. Retries, timeouts, and circuit breakers are just literally the way Poly implemented them. They use the Poly package. If you used Poly before, that's what this is. Right? There's nothing special in there in terms of that. If you haven't used it before, Poly is great. You can use it to execute arbitrary code, arbitrary tasks with the same type of policy build-up that I have. All we did was kind of say, you probably do a lot of HTTP, so let's like special case this HTTP case by integrating it with our outgoing pipeline. We use some Azure storage queues. They have a really good SLA, so they don't go down very much. Their geo-replicated queues were designed to try and give some ridiculous number of 9s. In the code, although I didn't show it much, we call this method called add key per file. Add key per file allows you to load Kubernetes config maps and secrets into your .NET Core application. So in this case, all of our connection strings come from Key Vault. They get injected into the container at runtime in a memory-only volume mount, and then get loaded into the application without them ever being in any config files or on disk anywhere outside of the Key Vault instance.
So you kind of see here, and
yeah.
I don't mind you showing that secret.
Yeah, the Kubernetes name is important. All of our config was secrets because we did the secret connection string, and then we just kept adding more things. It didn't really matter if they were secret or not. What was the other thing you had?
The last one you really want to, that's the other one that bit us.
So when you click the button and it said got it, that used temp data in ASP.NET Core. Temp data puts that message in a cookie, right? When we scaled out the web nodes, anything that required you to issue a cookie means we weren't implementing any stickiness. Right? Every time one of you hit that URI, you were going to go to any random node, right? Whatever the load balancer decided to put you on. By doing this, to add data protection, persist keys to Azure Blob Storage, effectively we put the keys to validate the cookies that we provided off of the nodes, which meant they all could validate each other's cookies, which meant it didn't matter which one you came back to, everything would be fine.
So the error, because this is usually me finding an error and asking Glenn, what the hell, how do I fix this? I was seeing anti-forgery.
Cause errors?
Anti-forgery token errors. And it was information, so I just ignored them. But I couldn't figure out why the text wasn't showing up. So that's what was happening. The key was going back to another node because, of course, we want to bounce around. So that was just a little clue to be able to take a look at.
Yeah. So all this stuff is in the GitHub repo, so you can look at it. There are things you should look at when you go into containers or go into Kubernetes.
So there's lots of talks. I see people trying to get to the next one. That's great. We'll wrap up. We'll stick around. The talk I give tomorrow, I'll drill into some more detail there.
After this, I'll probably be down at the ASP.NET booth, so you can come ask me questions now. If you want to ask me anything else, I'll probably be down in the expo hall, and I'll probably be there again tomorrow or something. Definitely all night tonight. Yeah,
and we'll be down at the ACR booth as well for all kinds of questions.
Cool.
Thank you. Appreciate you guys all showing up. I'm really thrilled to see like so many people adopting this stuff now.
That's the end, but I have one demo just to reward everybody else who stayed.
Oh.
Okay, all you guys that left, sorry.
All right, hold on.
Switch back to my machine. I didn't show you this. So I didn't show you this because I was running out of time, because we hit almost exactly on our time limit. One of the things I did wrong in this example, which will be when you go to GitHub, it'll be a completed branch, so all the code will be as it should be at the end. But the add transient HTTP error policy doesn't actually handle that timeout exception that I showed you earlier, the poly timeout one. So in here, you need to say .or timeout rejected exception. Otherwise, the retry won't retry when a poly times out. It'll only retry when you get HTTP errors.
Oh, that's why I was seeing it. Anyway.
So that's why you would, yeah, okay? So remember to do that too, for anybody who tries to copy this at home.
So with that, thank you. We really appreciate you guys coming.